I want to go over this problem because there is some subtle math here that you might be rusty on, and also because the second part uses a technique that we have not explicitly used in this course yet. So let's go ahead and read the problem. Polarized light is incident on three polarizing sheets. The axis of the first polarized sheet makes an angle theta with the plane of polarization. Each subsequent sheet has an axis that is rotated by an angle theta from that of adjacent sheets. Find theta if 43% of the incident intensity is transmitted by the sheets. So that's a mouthful, but actually it's pretty straightforward because we're just going to have to use one formula. This is called the law of Malus. This is what we're going to need for both parts of this problem. So I, that's the intensity that emerges from the sheets. I naught is the incident intensity, so the intensity of the light on the first sheet. N is the number of sheets, and theta is this angle that's talked about both here with regards to the first sheet and then also for all the adjacent sheets. And the important thing is it's the same for all of them. If it wasn't, it'd still be solvable, it would just be more complicated. But we're not going to get into that. We're keeping it simple. They all have the same angle, so we can use this formula just once. And again, it keeps it pretty straightforward. So 43%, it says 43% of the incident intensity is transmitted. So what that's really telling me is that I over I naught is equal to 0.43. So I'm going to put that over here in this formula, get rid of the I and the I naught, and I'm just going to have 0.43. And then I'm going to have the cosine, and I have three sheets, so 2 times 3 is 6. And there we go, 0.43 equals cosine to the 6th power. I should say cosine of theta to the 6th power. So this is one of the subtle math points I wanted to make sure everybody's clear on, because again, you're probably a little rusty, or I shouldn't say probably, but there's a chance that you're rusty on this, and this shouldn't be a stopping point for anybody. So the idea is, in order to solve this, the first thing you have to do is you have to take the 6th root. And if you've forgotten what that looks like, it's 0.43 to the 1/6. You have to do that on both sides. So I'm taking the cosine to the 6th power of theta, but then I'm raising it to the 1/6 power. So basically the golden rule of math, whatever you do on one side of the equal sign, you have to do on the other. So I raise this to the 1/6 and I'm raising this to the 1/6. The effect of this is this cancels this other one. So the right side just becomes cosine of theta. And of course, you can plug this into your calculator. I could have done that to get the value, but I'm just going over the process of solving it here. At this point here, this is where you can take the arc cosine to get the answer. And I'm going to go ahead and do it myself here and get the answer so that you can check to make sure you're doing it right on your calculator. And it comes out to 29.68 degrees. So that's the answer for the first part. For mine. Obviously you need to do yours, but this is the process you're going through. Now the second part is a little trickier. It says, suppose you want to rotate the plane of polarization of a beam of polarized light by 68 degrees, but you do not want the final intensity to be less than 86% of the initial intensity. What is the minimum number of polarizing sheets you must use? Okay, so this one, as I said, a little trickier. So what we've got here is, if I'm taking the law of Malus, now I over I naught is 0.86, but that is the minimum. I don't want it to be less than that. So 0.86 must be greater than, excuse me, I got that backwards. This is the minimum. Must be less than or equal to cosine of 2n of theta. So that's what is meant by, I don't want the final intensity to be less than 86% of the initial intensity. Now, this 68 degrees, let's account for this. So remember that the angle between the adjacent sheets is going to be the same. So consequently, that means that the total angle, this 68 degrees divided by however many sheets, that's going to be theta. This is a subtle point, but if I'm rotating all of them the same amount, then 68 degrees divided by n is going to equal theta. Okay, so that means 0.86 must be less than or equal cosine of 2n, and then I'm going to have 68 divided by n. And let me just, to make this clear, put parentheses there because the cosine is acting on that fraction. Now, at this point, one is tempted to go ahead and try to solve for n. And what you quickly discover is that you can't. This is called, at least not using standard techniques, this is known as a transcendental equation. And they are extremely hard to solve analytically. And in some cases, they may even be impossible. I'm not an expert on transcendental equations, but point being, this is beyond the level of math that we're using here. So how do we get the answer? Well, we're just going to go to an old tried and true approach that, again, we haven't used much in this class, not explicitly anyway, but just trial and error. Okay. So what I'm going to do is just say, okay, let's set up n. I'll set up a little table here. And I'm going to say, and this 0.86, remember that's the minimum of I over I naught. So that's what I'm getting there. And what I'm going to do is I'm just going to put in values for n, and I'm going to calculate what I get. So if I put in, we'll just start with 1. Okay. So then I'm taking the cosine of 68 divided by 1 is just 68. So cosine of 68, and then I'm going to square that. So I take the cosine of 68, I get the value, which is 0.3746, and then I square that. And after I do that, I get, 0. That works out to be 1403. Okay. Obviously, that is not greater than or equal to 0.86, so I move on. I try another one. Now, that's pretty low. I'm not just going to move to 2. 2 is obviously going to be too low. Let's jump up a little. Let's jump up to 4. Let's see what 4 is. Okay, so now I've got to take 68 divided by 4, which works out to be 17. I'm going to take the cosine of 17. That's 0.9563. Then I've got to take that value and raise it to the 2 times n, so 2 times 4 to the 8th power. So I have to take 0.9563, and of course there's more digits, but I got to take that and raise it to the 8th power. And when I do that, I get 0.6995 approximately. Okay, getting closer. Still a ways off from 0.86. So I'm going to move on to another value. I'm going to move up to 9. I'm going to say n is 9. And again, we're just doing trial and error. I'm just throwing a value in and trying to figure it out. So 9. So now 68 divided by 9. That works out to be 7.5555. Okay, I'll take the cosine of that. And I get 0.9913. And then I'm going to raise that to the 18th power. And that works out to be 0.8547. Okay, pretty close, but still not greater than or equal to 0.86. A little doubt that 10 is going to give me the correct what I need. But let me just do it all the same. So 68 divided by 10 is 6.8. So I'm going to take the cosine of 6.8, which is 0.9929655. I'm going to raise that to the 20th power, and that works out to be 0.8683. Okay, so the correct answer here is I need 10 sheets. So this is trial and error. One thing I need to emphasize, we need greater than or equal to 0.86. If this value here, it was 0.8547, well, let's say it was 0.8597. That is not greater than or equal to 0.86. It can't round up to 0.86. It has to be, when you calculate it, it has to be greater than or equal to 0.86. Because this is the minimum. So 9 sheets doesn't get the job done. You need at least 10 sheets. This is the correct answer.